Hello everyone, and welcome to BFW 2401. This is part 2 of week 7, and we are continuing with the modeling. So this is part 2. So in this model, in this part, we will talk about the new models for credit risk. As you know, we have talked about the old models, and the old models is actually the probability models, and they are the linear probability model. And we have the logit one. And we have the Altman, which is the Altman's model, which is the Altman Z, the discriminant model. Now we move now to new models called the term structure, derivation of credit risk. This one we'll take it in this part, and these 3 ones we will take it in week 8. Now I want you to understand for credit risk modeling, for the modeling, either they tell us 2 things. We want to know whether we should accept the loan or not accept it, and this we call it benchmarking. Or it tells us how much we should charge, which is the pricing. This is working with the selection risk, and this is working with the underlying risk. And some of them will tell us the 2, like the RORAC. The RORAC will tell us the 2. As you can see, this one is only benchmarking. This one is only benchmarking. This one's, the term structure is trying to tell us how much we charge, or it helps us to calculate the spread or the premium. Now, let me tell you what is the concept behind this term structure. So the term structure is working like this. It's telling us, this is actually the term structure. And the term structure is telling me, if I have $1, I can invest this $1 in corporate, or I can invest $1 in the central bank and get, in treasuries and receive something like the fixed, what we call the risk-free rate. So this will give me the fixed rate is I, and this will give me the K. The concept here, if there is no credit risk, if the corporate is AAA, for example, and very well, so my dollar plus the principal should be 1 plus I. So this will be an equality and no problem. But actually, most of the time, this is not true, because there is, and this is the facts of life when we invest in corporates, there is always defaulting when there is a credit risk. So this credit risk, to count it, to bring it to the picture, there is a probability of payment of my $1 plus the K should be equals the $1 here plus the I. This is the whole point here when we talk about the term structure. And therefore, if we can say now, I can calculate the probability of payment, which means I can say it's 1 plus I, 1 plus I equal over 1 plus K. So if the I now is, say, 10%, and the K is 15.8%, I can say now the B is actually 1.10, and this is 1.58, and this can be 95%. So if the probability of payment 95, the probability of defaulting, which is 1 minus B, this is the probability of defaulting, it will be 1 minus 95%, or 1 minus 95 of 1 minus B, and should be 5%. This is the whole issue. So if you want to withdraw it, it's just like this. If you can withdraw it like this. For example, if this is the risk. What is the risk now? Our risk now is probability of defaulting. This is the defaulting because we are talking about credit risk. This is the default. And this is actually the return. This is 0. If I invest in corporates and in risk-free, it will be like this. So this actually will be 10%, which is the risk-free. And this will be, according to this calculation, is 18%, 15.8%. If I know this, because I know this 15.8%, this one like this is 10%, which means now that will give me a 5% of defaulting, because the defaulting is the probability of defaulting, which means I can withdraw it now like this and say this, actually this area now, if you look at it, this area is 5%. For defaulting 5%, I'm receiving a difference of 5.8%, which is the difference between K minus I. This is how this defaulting, how this what we call how you get the premium. So the premium, if I know the probability of defaulting, I can actually calculate the premium. Just one more thing now. There is something called, let me just bring it here, something called sometimes the collateral. And let's take the collateral and call it, this is the collateral. Now, when we talk about the collateral, which means if we want to talk about the payoff now of our investment, it will be our my dollar plus its interest, which is, and their probability, plus my dollar, the probability of defaulting, my dollar plus the K times the probability of defaulting, which is 1 minus B. And then I can multiply them by, this is the 1 plus K, by the lambda, which is the probability of, which is this one, which is the collateral. So the payoff now will be 1 plus, this is the probability of payment, this is the probability of defaulting, and all of it actually should equal 1 plus I. If we know this now, we can calculate actually, we can calculate, they give us another formula. I'm not going to give you the proof, which is the K minus the I is actually the premium. And this premium equals the following: 1 plus I over plus B minus this is actually, if you look at it, this is the 1 plus K. This is the 1 plus K. If you minus it from the 1 plus I, It's not you minus it, you just bring this amount here. So 1 plus I, you can get the premium. So it's 1 plus I, this is 1 plus K minus 1 plus I, it should give you the premium. This is the whole story behind the, if we understand it from this perspective, we will be very happy. So now when I explain it to you here, it's very easy. So actually, as I said, B1 plus K equals 1 plus I, which we agree about it. Now, when we bring the collateral, which is the probability of defaulting, this is the payoff, the probability of defaulting plus the probability of payment should equal 1 plus I. So if the collateral more than 0, which it should be, then in this case, the required premium will, for any 1 minus P, which is the defaulting, this is the defaulting, should equal this amount, which is just a formula I show you. This is actually 1 plus K. Which is the probability of payment. This is the probability, this is the payoff. This is the whole payoff. Which is the probability of payment and probability of defaulting times the collateral. This is the whole thing behind this formula, and I hope to get it from this way. So this is actually the probability. This is the payoff, the whole payoff when there is a collateral, and this is of course the central bank. Okay, let me go now to, so this is just another calculation. It's the same thing, and this is how it works. So this is year 1, this is year 1, for example, year 2. And this line is the probability, this is the treasury, which is the I, the risk-free, and this is the corporate bond, grade B, for example. And if you calculate, you can see this real data. It shows for the first year the difference between 10 to 15.8. So the difference is 5.8. And then we go to the next year, this spread increasing. And there is nothing to do in this slide. It's just telling you it's when it is 10%, and this is 15.8% the K, then we can calculate the probability of payment for 95. I think I have talked about all of this and told you this premium can be 5.8 without collateral. When we bring the collateral, then the collateral, if we assume the collateral is 90%, which means it covers 90% of our loan, then see how much the drop in the premium. This is just, I used to have 5.8, it drops now to 55 basis points. This is because we guarantee 90% of our loan is coming from the collateral if it defaults. Now, what if this is going to go down? Say it's 50%, this will go up. For sure, it will go up, the premium. So there is actually a relationship between B and there is a relationship between the probability of payment and the collateral. If this is the collateral and this is the probability of payment, this line will be like this. The less the probability of payments, the higher the payment. So if there is a customer comes to you with a high probability of payment, you ask for him a little collateral. If he has high probability of defaulting, you ask him for higher higher collateral. So collateral is actually, so this collateral and probability of payment is perfect substitutes, and understand it from this perspective. So when a customer, I told you, he's very, has very good history in credit risk, of course, you will ask him for, and he has high probability of payment, you will ask him for a very less premium. And if he comes with also collateral, or a customer comes with the collateral, and that collateral covers 100% of the loan, which means the premium should not be there it should be not there if you are talking about credit risk. So, and of course, there is no collateral 100%, they make it less than that. The other thing is, this is the second model, which is maturity rate derivation of credit risk. This is a very simple issue, and they use it actually for bonds. And all of you have to do, if you are going to invest, you just do the following. You calculate the total value. For example, if we are interested to invest in class B. So we take all this class B here, total average bond defaulting over the total value of grade B. And we will see then the MMR. MMR is marginal mortality rate, which means how fast this will die. So here, for example, in year one, if it goes like this is very risky. Or like this, it's very steep. If it is very steeper, then if it is less steeper, that means the risk is less, going less. So this is telling me that the number of bonds that were defaulted in year one in this class was this number here, and in year two it goes a little bit here, which is very logic. Defaulting is related to maturities, and it goes like this. So I told you if this line is steeper, that means the credit risk is higher. If it is less steeper, like this line, then in this case it's less. So they give data from the US and they show you, and you can see, for example, this is AAA, all these issues of bonds. And you can see, for example, AAA, no defaulting, third year, fourth year. So this line will be just here, maybe. Then it will increase, I think, in year 5. Then in year 5, it will just started here. A little bit, the curve will start to go in year 5. The first point here, and then dropped. So you have 1 point here, 1 point here, But if you talk, for example, about rating, if you talk about C, it's 786 from the first year, 15,830, 18.6. So all of those actually is going up, is related to the rating. The more, which means the rating agencies are doing good job. I mean, if we assume they are doing good job, according to this data, their rating is right. The AAA is not defaulting. And when you go down the rating, they start to default. This is one thing. The other thing, there was just some information here about this. This actually was related to the defaulting of WorldCom and Enron. WorldCom, I think they have some bonds there. So they actually, in because this is from 1971 to 1981. This is one of the years where they default. So this is the last 10 year, I think, from 2001 to 2009, I think, yeah. So this is actually, they default in this year. This is 2001. Yeah, this is the year 2001 when they defaulted actually. So if this is from 2000 to 2009, this is when they default during that crisis. So all we want you to know is this graph and how it works in MMR. I think I'm done for this part. Thank you very much. And hopefully